All right, so here's the first of the homework in section 4.4 that's actually covering new content, and I'm going to be looking at question 3A. If you want a paper version example to follow, example 3 from the textbook, it follows this type of problem. So if you want a slightly different approach on how to solve them, take a look at example 3 in your textbook. It can be quite useful as well. So let's go on and take a look at what's happening here. So in question 3, they're asking us to determine the exact roots for each trigonometric equation or statement in the specified domain. So remember how to read domains, and keep in mind the reason I'm talking about trigonometric equation or statement is we're also dealing with degrees and radians. So when you're walking through, keep an eye on which one you're talking about, okay? You might have to switch up your calculator depending on what you're doing. Or you may not. But remember, keep in mind, if you're working in degrees, your calculator should be degrees. If you're working in radians, your calculator should be in radians. Now I'm going to do 3a, which is 2 cos theta minus root 3 is equal to 0 on the domain theta greater than or equal to 0, but less than 2 pi. So let's go see how would this work. Now, don't get worried by this cos theta part. Just pretend it's x for a moment if that helps. So it's the same as 2x minus root 3 equals 0, and you know how to solve these. So first things first, you need to get all your like terms on the same side of the equation. So if this is 2x minus root 3, then I need to get my root 3 over there. So that's just going to become 2, that should be 2 cos theta equals root 3. So that's the situation going on there. Now I need to get rid of this 2, so let's divide by 2 on both sides, and I'll get cos theta is equal to root 3 over 2. So that's what we have in this situation. Now, if I want to find out what is this on my unit chart system, I'm going to have to think back to some of my earlier triangles. Just keep in mind, cos here is x. It's going to have some coordinate of root 3 over 2, and then I'll have some kind of y coordinate. Now, if you go back and take a look, I believe it's on page 192, it'll give you a listing of what all the different equations are for both pi over 6, pi over 4, and pi over 3. And if you do that, you'll find out that the y component here is a half. So it ends up being root 3 over 2, comma, 1/2. So if cos is x and sine is y, then it means I'm dealing with something in this quadrant 1, because this is positive and that's positive. So it has to be quadrant 1 because it's the only place where both are positive. And root 3 over 2, let me clear up this work because I actually have those answers sitting there for you. Root 3 over 2, reference from the book, is here, and that's pi over 6. So we're dealing with this triangle right here. I'm a little bit off, sorry, but this is the triangle that we're trying to solve for. Okay. And keep in mind, again, that's because we're dealing with a positive x. So now I'm going to want to think about if there's any other possible answers in this area. Because keep in mind, I'm talking about 0 less than or equal to my theta, which is less than 2 pi, which means that any set of answers that matches this within this range is valid. So this range includes 0. So if it happened to be sitting on 0, that would count. And it goes all the way around the circle, once, but would not include 2 pi if 2 pi was a valid response. So down there, the other answer will be this one here. Because here, this one's positive and that one's negative. So this would be the other valid response because this is positive, and when you're dealing with cos of pi over 6, the only thing that matters is that the x needs to be positive, and this is our positive x here. None of these answers would be valid because that's your negative x in that direction over there. So the positive responses that you're going to get will be pi over 6, which I just took from the circle, or what this pi over 6 here is. Now, if you're looking in the circle, you would have had it, but let's just double check through math what that would be. So we know if I go once all the way around the circle, that'll be 2 pi. So this will be 2 pi minus pi over 6. Well, if I'm dealing in terms of pi, double that would be 12 pi. So 12 pi over 6 minus 1 pi over 6 will be 11 pi over 6. So those are the set of answers that I'm dealing with in that situation. So that's all you need to do there. I hope you found the video helpful, and I'll see you in the next video.